This tutorial is looking at examples using Pythagoras theorem to find the third side in a right-angled triangle. So example A is a right-angled triangle with side lengths 6 and 3. Your first step is to label your sides of your triangle. So opposite the right angle is always going to be your hypotenuse or your C value. It doesn't matter where you put A or B, so A could be 6 or 3 and B could be 6 or 3, just as long as you've labelled your hypotenuse correctly. Writing out our formula for Pythagoras' theorem, we get c squared equals a squared plus b squared. Substituting in our values for a and b, we have 3 squared plus 6 squared, giving us 45. Now we're not after c squared, we're after c. So in order to solve for c, we take the square root of both sides, leaving us with c equals the square root of 45. Now 45 is not the simplest surd, so we're going to simplify that. So we note that 45 is the same as 9 times 5, where the square root of 9 is a whole number. So the square root of 9 times 5, square root of 9, square root of 5, leaving us with a result of 3 root 5. Now you might want an approximate answer to that, but I'm going to leave my answer in surd form. Okay, example B is another right-angled triangle with side lengths 7 and 2. Again, first step is to label our sides. So hypotenuse of C, 7 is A and 2 is B. Writing out my Pythagoras' theorem, c squared equals a squared plus b squared, and now substituting in the values. So I know that A is 7 and B is 2. C is what I'm trying to find. So c squared is going to be equal to 7 squared plus 2 squared, where 7 squared is 49, 2 squared is 4, leaving me with a result of 53. Again, I don't want c squared, I want c, so I'm going to take the square root of 53. That can't be simplified any further, so that was my end answer. Example C. Again, a right-angle triangle. However, this time we're not trying to find the hypotenuse, we're trying to find one of the other side lengths. First step is still to label our sides. So we're going to label 7.4 as C, 3.6 as A, and we're going to try to find B. So writing our Pythagoras' theorem, c squared equals a squared plus b squared, and substituting in the values we know. I'm then after to rearrange this. So I want my b by itself. So it's easier to do this if we remove the squares. So we've squared it, and then we're going to minus that 12.96 from both sides. So I'm getting rid of everything that's with the b. So minusing 12.96 from both sides is going to leave me with b squared by itself, and my other side is going to be the 54.76 minus 12.96. This gives me a result of 41.8. Again, that is b squared, and we don't want b squared, we just want b. So b is going to be equal to the square root of that. It is an approximate answer, it's not an exact answer, so the squiggly equals means it's approximately 6.47, and that's the end answer. Our last example D, so 6.5 and 9.9, again, first step, label your sides. So C is going to be the 9.9, A is 6.5, and we're trying to find B. Substituting in the values we know, and then squaring those values, and rearranging. So this is going to leave us with b squared equal to 55.7. So I've done 9.9 squared, I've minused 6.5 squared, and that's left me with 55.7. Taking the square root of both sides, I'm going to get 7.47, and that's going to be my end answer. Again, that should be a squiggly equals because it's an approximate equals, not a exact equals. The last example is a worded problem. So in this particular case, Tom is afraid of heights above 9 feet. So this is one piece of information. He is asked to repair the side of a high deck. The bottom of a ladder must be placed 6 feet from the deck, and the ladder is 10 feet long. How far above the ground does the ladder touch the deck, and is Tom afraid of the height? Now, thing to note for this particular question, I have highlighted in different colours, and the different colours are representing different parts of the question. So the pink represents an end answer, The blue is also an end answer, and the green is the information we need to be able to find that end answer. So I'm going to start by drawing a diagram. So my diagram is going to show this deck and the ladder against it. So in this particular case, I've got my ladder here. This is what we're calling a deck, and this is the ground. So the ladder is placed 6 feet from the deck. The height is what we're trying to find, and the ladder's 10 feet long. So opposite my right angle is my C value, and then it doesn't matter where you put A and B. Writing out Pythagoras' theorem, so C squared is equal to A squared plus B squared, and substituting in the values that I know. So I know 10 and 6. This is going to give me 100 equals 36 plus x squared, where I want to get x by itself. So I'm going to rearrange this by minusing 36 from both sides. This is going to give me 64. So this x squared is equal to 64. We need to find out what x equals, not x squared. So we're going to take the square root of both sides, and the square root of 64 is 8. So the height up the deck is 8 feet. Now this question says, how far above the ground does the ladder touch the deck? So that's part of our answer. So the ladder touches the deck 8 feet above the ground. One part done. But that's not the end of this. This question's also asking, is Tom afraid of the height? If we look back at the original part of the question, it says Tom is afraid of heights above 9 feet. So 8 feet is smaller than 9 feet, which means that Tom is actually not afraid of the height that he'd have to climb to repair the side of the high deck. So that's the second part of our answer, and we would box that entire sentence or that entire answer. That's the end of that question, as we've answered every part that we highlighted.